Module 1.7, Force. We have a few more terms to learn in order to be able to understand the basics of acoustics. Force is the amount of effort required to move a mass. We can think of force as a push or a pull. If I am pushing a pencil across a tabletop, it requires a small amount of force. However, if I push against the wall, to move it requires more force than I'm able to produce. Force equals mass times acceleration. The units for force would be kilogram meters per second squared. We combine those into a unit called a Newton, named after the cookie. Not the cookie, of course. It's named after Sir Isaac Newton. So 1 Newton equals 1 kilogram meter per second squared. In this course, the only acceleration that we are going to discuss is the acceleration due to gravity, g, which is 9.8 meters per second squared. What does 9.8 meters per second squared mean? Imagine that you take a bowling ball to the top of the science building. You go to the top and, as an experiment, decide to drop the ball and measure its progress. You would find that in the first second, the ball would drop 9.8 meters, or about 30 feet. Since the science building is not much higher than 30 feet, your experiment would now be over. But if it was higher, you'd find that in the second of descent, the ball would drop 9.8 plus 9.8 meters, or about 60 feet. The distance traveled each second increases by 9.8 meters. That means the speed increases each second. That change in speed is called acceleration. Getting back to force, weight in pounds is actually a force. Since most of the time we are dealing with weight and mass on Earth, we consider them to be the same. But if you were on the moon, gravity is less. On the moon, you would have the same mass, but you would weigh less because the force of gravity exerted on you is less. In other words, your mass in kilograms would be the same, but your force in newtons, or pounds, would be less. So how much force is 1 newton? The force caused by gravity pulling on a 1 kilogram mass would be 1 kilogram times 9.8 meters per second squared, or 9.8 newtons. We said before that 1 kilogram equals 2.2 pounds. So if 9.8 newtons equals 2.2 pounds, dividing both sides by 9.8 gives us 9.8 newtons over 9.8 equals 1 newton, equals 2.2 pounds divided by 9.8, which equals 0.224 pounds. So 1 newton equals 0.224 pounds, or about a quarter of a pound. So the force exerted on your hand as you hold that quarter pounder from McDonald's is about 1 newton. In a previous section, we said that there are 454 grams in a pound, or 0.454 kilograms. So a 100-pound woman would have a mass of 45.4 kilograms. She exerts a force of 45 kilograms times 9.8 meters seconds per squared, or 445 newtons on Earth. The big picture. Force equals mass times acceleration. Since mass and acceleration are both in the numerator, they are directly proportional to force, so an increase in mass or acceleration would cause an increase in force. To review, F equals ma, or mass times acceleration. F equals mg, or mass times the acceleration due to gravity. G equals 9.8 meters per second squared. The force of 1 newton is roughly a quarter of a pound.